So this is going to come out to 1.13 times 10 to the minus 18. Now, we want to double check our answers here. So let's just double check our K, make sure that still works out. What did you get? 3.99 times 10 to the negative 13. Yeah, well, it's supposed to be 4.2 times 10 to the negative 13. And so this is starting to have me worried that there's a calculation error rather than a round off error.
I got 4.19.
What did you get?
4.19.
4.19. We have to watch out. This is why I carry extra digits, because if we start rounding these numbers here, the number can come up way off. 4.19 is good. 4.19, that rounds to 4.2. Is that what other people got? Okay.
I don't know if that messes it up or not.
Yeah.
It does, yeah, you're right. Because I did 6.3 times 10 to the negative 8 instead of that.
Actually, it should have worked too.
It should?
Yeah. Double check that calculation, because either way should have worked.
So I did 6.3 and I got 4.12.
4.12? Okay. If you round this here, you'll get 4.12, you said? Well, 4.12, is that close enough? I don't know. You're going to start to worry. And so you should make a habit of carrying extra digits to try to minimize round off error, because, or, you know, the other thing is you can always go back and check it. All right, so did this step perturb the previous step? No, I mean, there's pretty much no change in these concentrations. And so stepwise is fine. It didn't perturb the previous step. Okay, the next thing is this. This is back to the side point. This is why the combined method fails here, because look how much phosphate we generate. We generate 10 to the minus 18 molar, but there's significantly more monohydrogen phosphate and significantly more dihydrogen phosphate. So this is what we mean by mass is not balanced. And so we can't ignore those other species, because those other species are present in much higher concentration. And so this only leaves us with one more step left. Right? And that final step is water. And so this will be step 4. Let's just finish this one really quick. And so this is going to be H2O liquid plus H2O liquid. This is going to give us hydronium plus hydroxide. And so what we're going to do is the monohydrogen, this is the end of the line. So this will be the final concentration of monohydrogen. But this is not the end of the line for hydronium. This is going to go into step 4. We're going to add some more hydronium. Phosphate, this is the end of the line for phosphate, and so that's what we end up with here. And so the hydronium from the previous step is going to be 0.0233 ... molar. And we're going to assume that no hydroxide has been generated yet. And so this is going to be allowed to react. And so we'll have 0.0233 plus X molar and X molar here. KW is 1.0 times 10 to the minus 14, which is equal to the hydronium times the hydroxide ion concentration. And so this is going to equal 0.0233 ... plus X times X. We try the simplifying assumption, see if it works. So SA 0.0233 times x, and x is equal to
4.29 and 10 to the negative 13.
Okay, the percent change here is, the change is 10 to the minus 13. The initial is about 10 to the minus 2, we'll just call it 10 to the minus 2 times 10 squared percent, which is going to give us for 10 to the minus 9% change, which is fine. That's good. And so did we get much more additional hydronium? So this is 0.0233 plus, we're going to get 4.29 times 10 to the minus 13, so that's 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 6, 9, 12 zeros. And at 429. Did we get much additional hydronium? Barely any. And so this is not going to perturb. We got a negligible amount of hydronium. The odd thing is we get more hydronium here than we got in step 3, even though K is smaller. And so this is kind of weird, but that's the way that it worked. But did we get a significant amount of hydroxide? Yes, we did. And so that's why we went all the way to step 4. Not because of the hydronium, but we wanted to see how much hydroxide we generate. It's going to be 4.29 times 10 to the minus 13 molar. And so this is the end of the line for hydronium and hydroxide. So this is 0.233. This is up for molar. And so we'll just summarize this next time. Are we out of time? Yeah. Are we out of time? What time do we end? Yeah. Okay. All right. Sorry, I went over a little bit. Fix it next. Is there anything to do this week? Yes, there is. The formal lab write-up. Yeah, on Thursday. No, we don't have a test this week. Next week we have a test. It's chapter 16. We'll finish up chapter 16 on Wednesday. That's it. No.